Hi everyone, in this video we are going to solve a new problem. The problem name is added distance and the problem number is 72. Alright, so first of all we are going to clearly understand what this problem says. After that we are going to move to the logic part, and after that we are going to implement our logic in C++, Java and Python programming language. Now let's see what this problem says. Given a two string word1 and word2, return the minimum number of operations required to convert word1 to word2. Alright, so we are given the two words. The first one is word1, the second one is word2. Fine. And we have to convert this word1 to word2. Alright, by using a some number of operations. So what are these operations? The first operation is insert a character. We can insert anywhere a particular character, any character, right? In the word1, right? And delete a character, we can delete any character from this word1 as well. And replace a character. We can also replace any character with any other character in this word1, right? But all these operations gonna take one, we can say 1 unit of time, right? So we have to return how many operations we need to make this particular word1 to word2. So let's understand this example with this particular problem with this particular example. First one. So we have a first string, we can say horse, and the next string is rose, right? So we have to make this string to this string, right? By using all these three number of operations. So you can see these are not same, right? So we have to use some operation. The first operation is, you can see H and R are not same. So what I can either do, I can insert this particular character I, R here, right? I can insert R in front of H, right? So it will become equal. Either what I can do, I can say just remove this particular H. So it will also gonna be remove the H. Then also we can say we are left with 4 and 3 words. Either I can replace this H with R. So let's say I replace H with R. I use a third operation and I made H to R, right? Fine. After that you can see O and O are same. Fine. Fine. Now let's move ahead. And you can see R and S are not same. So what I'm gonna do, I'm gonna say remove R. I'm gonna use a second operation right now here. So I remove the R here, right? Now you can see S and S are same. Now you can see there is no character in the word 2, but there is one character in word 1. So remove this particular one as well. So again I use a second operation and I make this particular string horse to rows by using a three operation. First is replace, second and third is delete, right? So this is how you can solve this first example, and you will get an output 3, right? You use a 3 operation. Now guys, this was the problem. I hope now you understood. So now if you know this problem, particular problem, if you understood the problem what this problem says, now let's move to the logic part and try to understand what is the logic. So I'm going to write here logic, and guys, logic is going to be nothing but dp. As you can see that we have a choice, right? Here you can see we can either insert a character, either we can delete it, either we can replace it, right? So we have a choice. We can do any of these operations on a particular word one, right? So if you have a choice, definitely there is going to be recursion, and recursion can be solved by using a DP sometime, right? So now guys, there is a DP, and you inside of DP we have two things. First is bottom up. Let me write a bottom up, and second one is top down, right? So you know what is top down? Top down is nothing but memoization. If you are using it in recursion memoization, and bottom up is nothing but tabulation, right? You are going to make a matrix, and you're gonna traverse over there, right? So first of all, let me tell you what is this bottom up, how you can use this bottom up in this particular problem. And we are going to solve also the bottom up in Python, sorry, in C++ and Java. And I'm going to use a top down because it is a recursion. So recursion is in Python. So I'm going to use it top down in Python. Fine. Now guys, let's see what is bottom up, how we can use a bottom up in this edit distance. So guys, here you can see that we have a word as horse, right? Fine. What I can say that horse and rose. I'm going to tell you first of all bottom, or we can say let's say a top down as well, right? So top down is going to be nothing but recursion, right? So you can say if let me make it clear, the first character of this string and the second first character of other string, right? So you can see H and R, right? They are not same. Then either we can insert it, or either we can remove it, either we can replace it, right? So what I can say, first time you can check it by replacing it. So you can say make you can replace with each R. Fine. And now keep solving it, but you haven't added one solution, right? So now you can solve it. Otherwise, what you can do, you can say this H, you can remove this particular character, right? But if let's say I have this initially, let's say I have an H and R, right? And if I replace this character with R, then what I'm going to pass it here? Let's say this is I and this is J, right? So let me take a different character. I know it is becoming a very complex. So let's solve it in another way, because otherwise you will not get an idea. So first thing is nothing but word one, that is nothing but horse, right? And the second string, let me take another one, that is nothing but human, right? Because we have already solved that particular one. So now guys, you can see that first and first character I and j are 0. They are standing. I is pointing to word 1 and j is pointing to word 2, right? Both are 0 0, and first character are same. If the character are same, then you are going to pass it to I plus 1 and j plus 1 to the next tree. Means we are going to move ahead by 1 in both the string, right? If First character and second character are not same because in the next time we will say we have O and U, right? We have H and R same, so we move ahead. So we are going to remove this one. If second now again you can see that the character are not same. O and U are not same. If these character are not same, then what we are going to pass it? What I can do, I can say I can use this U in front of O. I can insert a U here. So if I am inserting it, then my word one is going to remain I, right? And this word 2 is going to move ahead by 1 because you can see if I inserting it here, that means I can say U and U are same and I can move ahead. So I can move ahead, it will come here, and I can move ahead, it will come here. So you can see that word 2 has moved ahead by 1 unit, right? But word 1 remains same over. So I can say I comma j plus 1. And if it is, let me remove this. If it is not the case, if I'm not inserting U here, what I can do, I can replace O with U, right? So what I can do, I can say replace O with U. So if I'm replacing O with U, then what I'm going to do, I'm going to again move ahead here and here because U are same. So you can say if you're replacing it, then you can move ahead by both of the word 1 and word 2. So I plus 1 and j plus 1. But if it is also not the case, let me undo it. And if it is not the case, then what you can do? If you either you have seen already by inserting and by removing, replacing. Now we can also remove this particular character. So if I remove it, then you can see that we are here and this has moved by 1 unit, but this remains same here, right? So we can say either we can remove I plus 1 and remain same j here. So now guys, if we focus over here, if the character is same, thus we have to move both ahead and we are going to add nothing into our operation, right? We haven't used any operation. But if character is not same, we can do this particular operation and we can take the minimum of these three operations and we can add 1 plus them because we are using a one operation by doing this particular operation. So this was the memorization and the tabulation is going to be later same only. No changes, nothing, just a matrix, nothing but all the same, all the things will be remain same. So if I again take the horse and rows example, so let's say this is nothing but rows and this is nothing but horse. Alright, so this is nothing but horse. And let me make a matrix. Alright, so this is nothing but horse, this is nothing but horse, right? Fine. Now guys, can you tell me that if I make a here character, let's say this one is the character, right? I'm here standing over I at 2, 0, 1, 2 and j as 1, right? Now guys, I'm at I is equal to 2 and j is equal to 1. Now focus over here. If the character is not same, you can see O and R are not same. Then this particular character represent what? What this particular character represent? This particular cell. This represent a cell that we have, what we have done. Tell me guys, this particular cell that represent has what we have done to this particular string and this particular string, right? So if I take another color and if I say, first of all, we are standing here, that means what we can say, guys, nothing but we have OS and nothing but RSC, right? We are standing over here, right? And you can see guys, O and R are not same, right? Fine. Now what we can do, we can either replace R over here, right? If we are replacing R over here, then what we are doing? This will remain same and this will gonna incremented by 1, right? But there's also one thing that is nothing but this one. If we are having a rows, right, RSC and this is O, right? So now guys, either what I can do, I can say remove this particular character O, right? If I'm deleting O, that means I'm going to here and this will remain same, right? So this is nothing but represent this one. So this says the delete, right? And if we are inserting it, this represent insert. And if we are doing nothing but replacing it, then this represent replace. If the character is not same, I hope this much makes sense, guys. Okay, so let me what I can do. I can say if the character is not same, then you can take minimum of these three things, right? You can minimum of delete, replace, and insert. Now let me move this. Okay, and guys, if it is the same, now here you can see if you focus over here, this R and R same or S and S are same. So if let's say this is character, if these are same, then we are moving ahead. So that is nothing but this one part, right? This is nothing but all we are moving ahead by both of the unit. We are moving ahead by word 1 and word 2 as well. So if we are, but in this case, we're not going to add one more, right? We're not going to add 1 plus this I plus 1 and j plus 1. Here we are going to add just 0 plus I plus 1 or j plus 1. But in on previous case, we are going to add 1 in all the case, right? 1 plus minimum of insert, delete, and replace. I hope this much makes sense. So this is nothing but tabulation. I know this is hard to explain in a one, we can say, video, but still I believe you have an idea what we are going to do in tabulation and I can say memorization, right? Now let's move to the code pad and see how we can implement our logic. So let me open my browser. Now guys, here what I'm going to do. So let me see the size first of all, 125. Yes. So what I'm going to do first of all in Python, I'm going to use a memoization. That means I can say we are going to use a top-down approach. So in top-down approach, what I can say, I'm going to use a recursion. So I create a function define solve, and this function going to take word one and word two, right? So in this function, what we are going to say, the base case. Let me write a base case. So guys, base case will be if word one is empty, right? If the first word is empty, then what we are going to do? We are going to add nothing but word two, all the characters of word two, right? If word two is empty, then what we gonna do? We can say return length of, sorry, I have to write there also, because we are not gonna return a string. We are gonna return how many characters that represent in that particular string. So I can say length of word two, right? If it is not the case, if word two is empty, then return length of word one, because we have to insert that particular character in the word one, right? Okay. Now what we have done? We have seen the base case. Now one base case more. If word one is equal to word two, right? So what I can say? I can say return zero. Fine. Now guys, we are going to use we can say a memoization. So for that I'm going to use a particular dictionary which is going to be work as like cache. Okay. Now I can say if this word one and word two are in my dictionary, that means I have already explored these things, then what can I say? I can return the answer which I got in that particular time. Word one and word two. I hope this much makes sense. Now guys, we are going to say one more condition, that is if condition are matched. If character are same, right? So we can say if character are same, that means we can say if word one of 0 equal to word 2 of 0, both are same, that but we can do, we can say return, or we can say answer. Our answer is going to be nothing but solve move ahead by one, both of the string, right? So word 1 is going to move ahead by 1 and word 2 also going to move ahead by 1, and we are going to pass TP as well here. And if it is not the case, then what we can say, answer is going to be nothing but, first of all, let take infinity. Okay. And if we are taken an infinity, then what we can say, or we can't take an infinity, let's just do here only. So it's going to be easy for us. So we're going to say minimum of, we're going to add one. First of all, we're going to use a one operation, and in after that we're going to say minimum of, let's first of all say that we're going to increment word one, right? We're going to increment the one. That means we are going to, what we are going to do, we are going to say just we are going to deleting that particular character, right? So we are incrementing word one, and we are going to say word two remains same, and we are going to say dictionary remains same. And another operation which I can do, I can say I can insert it. So word one remains same, word two gonna decrement by one, and we can say dictionary will remain same. The third operation which we are gonna do is nothing but, we're gonna say word one of one character ahead and word two of one character ahead. But this means nothing but we are gonna replacing it, right? And dictionary remains same. So once we are done this thing, so let me use it. All right. Now what we are gonna do? We are gonna say return. First of all, we are gonna say dp of. Let me come out from this else condition. Dp of word one, comma word two is gonna be nothing but this answer. All right. And here I can say return dp of word one. Let me add word one, word two. And once you are done with this, that means you have solved this particular problem. You have solved this particular function as well. So we can call this particular functions when solve. Let me write here return. Okay. And here we're gonna say word one and word two. So once we are calling it, let me write here return. Fine. Now let's try to run this code and see whether we are getting a correct output or not. I haven't used a double equal to sign. Let me make it. You're going to give an error. Yes, you can see that. Fine. Now let's try to run this code. And here it says that DP is not defined. Why it is okay? So I'm using a DP everywhere. No, only this case, right? So I have to make it D, right? Fine. Now let's try to run this code. And here also I have to make D. Use a D, not DP. Fine. Now let's me run this code. I believe it should work, right? No, again it's giving an error that is nothing but word one slash word two one slash and word one and word two one slash. So what is the error? It's saying that. Okay, so let me see the error. What is this? Error name is nothing but, okay, string and integer. So it is going to return somewhere a string. Where it is returning in that particular string? So we are saying that sol word one and word two and dictionary, right? Sol word one and comma word two and dictionary, right? Somewhere it has done, right? So we haven't passed a particular function here, right? We have to write here sol, and we have done this thing now. And here we are gonna say complete this function. Now guys, it will work definitely. Okay, let's see that. And you can see that both the test cases are passed finally. Now let's try to submit this code and see whether it's working fine or not. And you can see guys, my solution is accepted. So we have solved successfully this problem with the Python. Now let's move to the C++ Java programming language, and there we are going to use nothing but which approach we are going to use. We are going to use the bottom up approach. That means tabulation, right? So in C++, what I'm going to do, I'm going to say nothing but guys. We can say I'm going to create a first of all matrix vector, here again vector, and here I can say integer data types. And what is the size of this particular one? This particular size is going to be nothing but row, how many rows we have, and after that vector of integer, how many columns we have, and all the values are going to fill by 0. All right, so first is done. Then what I'm going to do, I'm going to say int n. How many rows we have? We have rows nothing but word1 total length, or we can say size. And how many column do we have? We have nothing but word2 dot size. Right? Now we are done with this thing. We are going to use a base filling. Let me use it as we are going to fill our base conditions in matrix. Fine. So we're going to say for int I is equal to 0, I less than. First of all, we are going to use with m, or we can say n, whatever you want to use. I'm going to say m, and here we can say I'm going to fill. What I'm going to fill? I'm going to fill my last row, right? So I can say dp of n. I can say dp of n, and here I can say nothing but my I is going to be nothing but m minus I, right? Okay, and I can also say for int I is equal to 0, I have to fill the last column as well. So I can say I less than equal to n I plus plus. So I'm going to fill my last column, that is nothing but dp of I comma n, and here I can say n minus I. So once I fill last column and last row, I can use my recursion. This can we can say top down approach, bottom up approach. So here what I can say int I is equal to what I can write here n minus 1 I is greater than equal to 0, because I'm going to start from the bottom, and here I minus 1. Okay, and here I can say for int j is equal to m minus 1 and j greater than equal to 0 and j minus 1. And once we are done with this, that means we are on a particular cell, that is I and j belong. So we can say if this word of I, word 1 of I is equal to word 2 of j, that means this character are same. So what we are going to take? We are going to take the cell which is I plus 1 and j plus 1, right? So we can say dp of I and j is going to be nothing but dp of I plus 1 and j plus 1. I hope this makes sense. But if it is not the case, then we are going to take a minimum. So dp of I comma j is going to be nothing but minimum of dp of, first of all we have to add one operation, right? So let me add externally, right? Okay, minimum of dp of I plus 1 j. So we have incremented the I, means we have what we have done. We have done nothing, guys. We have just deleted that particular character. Okay, so what we are going to do next is nothing but dp of, let me write minimum of dp of I and j plus 1, and the last one is nothing but guys dp of I plus 1 and j plus 1. That means we are replacing, let me add 1, and here j plus 1, right? So we are replacing it. Now once we are done with this, that means we have successfully solved this particular problem. So this was the only problem, that return dp of 0 comma 0. 0 comma 0 basically means that we are on the, we can say the zeroth index of both the string. That's what we want, right? Let me add a column here, semicolon. And why I'm forgetting this? Okay, let me run this code. Okay, you have to attempt it soon. So let me try to run this code now. And here, let me see. Again, it's saying that you are trying to access the indexes array, right? So what I have done here, I am, let me find it. What I am doing. Well, let's, so I have to use not n here, guys. I have to use m, right? Because this is nothing but we can say the last column, right? So now let's try to run this code. You can see that both the test cases are passed. Now let's try to submit this code. And here guys, this solution is also accepted. Now let's move to the last solution, which is nothing with the Java programming language, right? Okay, so I know about C++, don't worry. Okay, now here what we are going to do, we are going to do nothing but guys, first of all we are going to find the length. So I can say word1 dot length, we can see the size, both are going to do the things, but here we are going to use length and word2. So let me write n is equal to, right? We are going to say this is nothing but row and this is nothing but column. So word2 dot length. Fine. And here what we can say, now once we find the length, we are going to say nothing but we are going to create first of all tabulation matrix. So we can say int dp. So it is going to be our dp new int of n rows and m columns, and we are going to increment by 1 because we have to use last base condition for inserting how many rows and columns we have in the last rows, right? So int I is equal to 0 and I, we can say less than n equal to n and I plus plus. So what we are going to say, we are going to say this is nothing but a particular, we can say a column, right? So last column it is, so we can say last, it is the last column, and it's going to store nothing but the n minus I. And why we are storing this, if you know guys, on the last column, if nothing is on the, we can say the last string, if nothing is on a word 2, then how many number operation we require? We require all the characters, all the number of operation, what is the length of that particular word 1. If there is nothing in word 2 and we have word 1, then what, how many characters we need? We need all the 5 characters to make it horse. We can say to make it empty, right? So we're gonna doing this thing just for making our base condition clear, right? So if this is if we don't do this, then definitely we're gonna get a wrong answer. We're gonna accept that if there is nothing in word 2, that means there is nothing in word 1 as well, right? For int I is equal to 0, for int I less than equal to m and I plus plus. Here also we are saying that if nothing in one word, that doesn't mean that nothing in word 2. There may be something in word 2, right? So that's why we are doing with last row as well. So we can say this is n and this is I, which is going to be m minus I. Alright, so once we are done with this thing, we are going to say for int I is equal to 0, we are going to use a tabulation, not 0, I n minus 1 greater than equal to 0, I plus minus minus. And here again we are going to say for int j is equal to m minus 1, j greater than equal to 0 and j plus plus, sorry, j minus minus. Fine. Once we are done with this, we are going to check it. If word 1 of I is equal to word 2 of j, that means they are same. So we can say dp of I comma j is going to be nothing but same as dp of I plus 1 and j plus 1, right? But if it is not same, then what we can, so we can say that dp of I of j is going to be nothing but we have to add one, first of all, one operation, and we have to say minimum of dp of, not here minimum, math dot minimum, right? Math dot minimum of dp of I plus 1 and j, and same mat dot minimum of we can say dp of I and j plus 1. And the last time when we are we can say we are replacing that particular character, right? So dp of I plus 1 and j plus 1. Fine. Once we are done with this thing, we are going to say we are going to return our answer. So this should give us an answer, return dp of, let me return dp of 0 comma 0, and let me find out whether we have any error or not first. So I can see that so far it's fine, right? So let's try to run this code and see whether now we are getting any error or not. And it should not give, right? But it's still it giving us. So this is nothing but it's saying that array required but word found, right? So we are going to see what error we are going to have here. So here it says that array required but string found. So what does it mean, guys? So we are finding out this word, but we can't use this thing, right? Because in Java we can't use hashing, right? So we have to, what we have to do, we have to either use that add char. So we can say char add, here we can say I, and here also we can use a char add. When you use so many programming language, you confuse about it, what it's gonna take, right? Now it's gonna be work, right? Let me try to run this code now. And you can see that both the test cases are passed. Now let's try to submit this code. And by the way, you know guys, in the 3 programming language implementation, I got every time error, right? So you can see that this also submitted, right? So that's was the problem. I hope you understood the problem. So what we have done in top-down approach, bottom-up approach, and when we are taking the minimum and when we are just taking the I plus 1, j plus 1. If you still have any kind of doubt, you can ask in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.